that RC that you bought,
Mm.
what are we going to do with it?
Oh, well, I don't think it's fast enough.
It's not fast enough. You mean 170k down the main straight's not fast enough?
No, and the corners, it's a bit laggy out of the corners.
Bit laggy. Yeah. Okay. So we need to understand a little bit more about how it runs through the corners, and a bit more grunt.
Yep.
Bit faster down the straight.
Yep. And a bit more practice too.
Yeah. Bit more
practice.
Bit more practice.
Yeah.
Okay. Cool. I like the project. 380. Enough horsepower there?
I think twice would be good.
Yeah, you could turn it into an 800cc.
Yeah.
Okay. Well, we can't do anything physical with the motor, but what we can do is we could probably bump up the amount of air and then just fill bucket loads of fuel into it.
Oh, I like that.
You do like that idea?
I do like that, yeah.
Okay.
Yeah.
Yeah, okay. So we just need some bits, I suppose.
I've got some bits.
Oh, you brought some bits?
I brought some bits, yeah.
Oh, awesome. Yep. I didn't know that.
Yeah.
Oh, let's have a look at them.
So what we've got is, let's start with the first one. This could help, actually.
The air side of things.
Yeah, this could help with the air.
So air, rightio. Now, the problem with these is that they get really hot. The poor little bike's probably going to have a lot of lag because it's running off the exhaust or so. So we really need to spin that up and have it spun up permanently or under some sort of controlled way.
Right.
How do we do that? I reckon...
Maybe this.
What else you got in your box?
Maybe this. What else we got?
What else you
Not
got?
That.
Yeah, got something...
Not that. Oh, maybe this.
You got another...
What's this?
Oh, awesome. Look at this. This is...
I've never seen one of these before.
No, wacko. This is a 7 kilowatt brushless DC motor.
What?
And what if we took the hot end off that and we actually just dovetail that into there with a coupling on it? We need something to control this or so as well, but you know, maybe we'll find something at some point in time. What else you got in your box there?
What else have we got?
So if we took the hot end off, couple that onto it. Oh man, that is a Kelly DC controller.
Unreal. Okay.
And it's a good one. It's good for over 200 amps. Man, that is... And this motor here, that's rated at... Looking at the KV rating of this spins at nearly 100,000 RPM.
Fantastic.
That would put this turbo right in its little sweet spot.
Unreal.
I reckon we got something going here.
Okay.
So get rid of the hot end, couple the motor on it. We've got a DC controller here, which is perfectly suited to the motor.
Okay.
Okay, so things are starting to sort of look all right.
We're going to need batteries, though.
Well, we will need batteries. I reckon we'll probably need about a 17 amp hour, which will probably run that at about 120 amps max. Normal running load of about 80 amps. I reckon the battery's going to need to be about that, by that. So,
like this?
Hey, did you make this?
Oh no, just
found
it's in my magic. It's in my magic box of bike bits.
Yeah, cool. Okay. Oh, nice one. So that'll fit that.
Okay.
So we now we've got a battery, we've got a controller and a motor and a way to push more air into that thing. Now we have a few things we've got to do. We've got to measure the air. So what do you got? You got anything there we can actually measure air with?
What else we got?
Look at that.
There we go. How about that?
Now this looks to me like a mass airflow motor off a 1.2 litre Renault.
That should do the job.
Probably will.
1.2 litres. Well,
yeah. Okay. Well, that's all right because we got to
yeah.
rearrange it anyway. So we'll have to do a bit of a dry run with the motor running just in its naturally aspirated. Take out the signals and then see how that goes for the rev of the motor, and then you extrapolate that out to what the turbo is going to produce at a later date. Right. Okay. So we've got mass airflow.
All right.
And because we don't have a dump valve on this thing, we could have got rid of the hot end. We have to have a way of controlling turbo surge. So we have to have you know, it's probably like a controlled thing, which will have to probably be electrically controlled device.
Electric control.
Yeah, like a, what about like a throttle body electric? Man, look at it. What have you got?
There we go. Here we go.
Now,
That's what you're talking about, right?
Exactly.
Something like this.
Yeah. Okay. So this will.
I'm really impressed with this magic box.
Yeah.
Though. It's just seems to have everything we need.
Where does it all? What fills it up? Is it just sort of just dreaming and it sort of happens?
It seems to be. Yeah.
All right. So this is a throttle body. The good thing about these is it can control straight from, you know, an ECU, which we haven't got yet. But it is fast acting, which is really, really what we want, rather than a slow old, you know, like dump valve type thing.
Right.
So that goes into the delivery side. Beautiful.
Okay.
So this is all coming together a little bit, but we now need to have something which we can use to control everything. Now the bike's ECU is probably not going to be good enough because you can't really remap stuff in there. We need to be able to have all the bike sensors into it. We need to have fly-by-wire type control capability, and a massive amount of other stuff. So, and an output which you actually can control the motor through the controller. But I don't have anything
sophisticated.
It's getting beyond me. What have you got in your box there that might help us out?
How about one of these?
What, a cardboard box?
Oh no! The latest, the Max ECU Sport.
Max ECU Sport. And you know the good thing about the Sport is that it's actually got two fly-by-wire outputs, so it can control the actual bike's throttle body, which is fly-by-wire, and it can control the dump valve, which is also like a throttle body, but we're dumping stuff down to control turbo surge and boost.
Excellent. Well, that was a great find.
It was. Unbelievable. But you know what? Putting all this stuff somewhere is really going to be a problem because we've got a whopping great big fuel tank there that is just no good, you know, because you're going to be out there do like a 15, 20-minute run. We need about 5 litres of fuel.
Tops.
And so we really need to cut that down, and we need to find somewhere to put some of this gear.
Okay.
Anyway, look, we'll work on that one unless you've got something in your magic box.
Well, we could compress it down. Just so happens we've got a custom made.
What's this?
Custom made fuel tank just for the RC.
Right. So, okay. Look at that. So we could. I wonder whether these bolt holes line up. Hey. Isn't it magic?
Amazing.
That's a magic box. I love that box. Well, it goes this way, of course. Yeah.
Well, I don't start any project without one of these boxes.
Look, finding the right box is always the hard part.
Absolutely.
But once you find the right box, it sounds like it's got everything you actually need.
Yep.
Yeah, beautiful, beautiful. All right, so that can mount onto there. I wonder if it'll actually fit. We can work that one out in a minute.
Yep.
So the only other thing that I can think we might need is probably things like a new fuel pump's got to be on. We've got to get a fuel regulator. We're probably going to run E85, so we need to have like a flex fuel sensor. And I don't know where we're going to get any of that sort of stuff from. I don't even know what sizes we might need. Well, look, funny thing, there's something on the bottom of this.
Oh,
maybe there's something in the box there that actually fits in there. What have you got there? Hey.
Look at that.
What's that? That is a high flow fuel pump. Okay, so that looks like it's designed to fit into there. And that sits underneath. Rightio. Wonder what these brackets are for. Is that bracket? You've got something that looks like that might mount onto that bracket there.
What else have we got here?
You got like hello?
That looks like about the right thing.
That's a fuel pressure regulator.
Yeah.
Let's see if those holes line up. Magic.
Mate.
Eh?
Mate.
And look, it just clears the bottom as well. So this is the overflow. Let's just sort of see how that will work. So the overflow comes around, and I reckon that's what that is. So that goes back into the tank, and we got fuel in and pressure out. I reckon that looks damn good. That looks damn good. The only thing about it is that if we're going to run E85, we need to measure the ethanol content. We need an ethanol like flex fuel sensor.
Right.
So there might. What do you got in the box there?
That looks like what you're looking for, right?
That's exactly what we're looking for.
Excellent, excellent.
So we'll just stick that down. There we've got that one sorted, and I wonder, that looks like it might just pop into there. This is a huge find, mate.
Yeah.
Hey, how awesome is it?
Falling together. It is amazing.
It is. Yeah. That's it. Okay, now I've got brackets and stuff, and I'm sure we'll have to have a look to see whether that fits in. But you know, the other thing that I'm worried about, now, if I show this like properly.
Oh, yeah, I see.
Now, when you go around a corner and you're going to be at an awesome angle.
If my shoulder's not down, I'll be disappointed.
Yeah, me too. I'll be disappointed. Yeah. And so, what happens when we're down to low fuel here? That's going to sort of suck air.
Yeah,
you don't want to do that.
Turn 11's going to suffer.
Turn 11.
Turn 11.
Yeah. So you'll have to sort of stand the bike up mid-corner.
Yeah.
Unless we go into some sort of a reservoir or whatever. I have to build one of those.
You need a surge tank. That's what you need.
A surge tank.
You need a surge tank.
Okay.
There you go. That fixes your problem.
So that goes somewhere under here, drains into there, then that one there, the big one there, goes into the fuel pump, then the fuel pump does what it needs to do, goes to the regulator, and then the regulator goes down to the injector. Perfect.
Excellent.
Lovely.
Okay, so we've got our RCDC 390 project bike here. This is what we're building it all off.
Yeah.
We got this end of 2025.
Yeah.
Around Phillip Island time.
Yeah.
MotoGP.
That's right. Down there with the trailer.
Yep.
Just so happened. And you rang me up and said, look, I found a bike. I want you to go and look at it. And if it's any good, chuck it in the trailer and bring it back, which is what I did.
Awesome. And we so it's a stat write-off. We picked it up for next to nothing. But everything on it is mechanically great. So engine's done about 500 kilometers. What was it, 2021?
2021 in the insurance yard for 2.5 years.
Yeah, sat for a while. A couple of little dings and bents, but we pulled most of it off.
Yeah.
So we've got what we need to build this bike.
So that came off.
That's also fuel tank's out. We've got the new radiator on there. What else? More or less everything. Pegs are obviously changed, but fundamentally this is raw RC390.
Yeah, so this is the design of the fuel tank, and it's only a 5-litre tank or so. We don't need much more for a 15 or 20-minute run, and we'll just fill it up between sessions. And it also gives us a way to mount all the other stuff. So it basically just sits in right here where the original one was, and it anchors down onto the two mounts there, side mounts through here, and underneath is where the fuel pump goes underneath there. You'll see the bracket under there, and the fuel pressure regulator sits just in front. The E85 flex fuel sensor is on this side, out of the way, and the controller sits on the top.
Max ECU,
yeah. Yeah, the max ECU, yeah. This is just a breather for the tank. This is the filler for the tank, which will all get cut down and connected up. This is the return pipe from the pressure regulator, and the other side of the pressure regulator just goes straight to the injector. So that's all that part. What we've also got is this, which is a surge tank. It's just a little thing there to prevent the pump from running dry while we're on big lean angles. And I couldn't think of any other way to do it. So it's going to sit just in here. Without too much hassle, I think. Yeah, it'll just sit in there like that. I'll make up a little bracket off there to mount on the original brackets. The output side, which is here, just return up through here, up to the pump, and then the pump goes to the regulator, and then from the regulator down to the injector. And that's basically just going to be gravity fed from the tank here, this intake here, gravity down into there. The other little pin there is a breather. So that breather just pipes up to a T-piece up here, and that just gives this a little bit of breathing point, and it's high enough so that it's not going to overflow.
Yeah, cool.
So
okay, so we're waiting. So basically, we just got to touch up this fuel tank. We've got a few little leaks we're going to fix.
Yeah.
Then we can mount this off, and then we can start mounting the ECU and a few things, and we can basically look at getting this engine running.
Yeah. 100%. The engine running is in parallel to getting the dash sorted out, because they go a bit hand in hand. And because the motor's never run before, and there's so many changes that we're going to introduce, we decided it's probably better off just getting it to the point where it's a naturally aspirated, no frills motor, but with all the engine control add-ons, the new fuel, and the new dash.
Yeah, cool.
So that can prove the controller works. Controller talks to our dash. The dash displays information on the screen.
Yeah.
And that's step one of the bike.
So okay, so critical work, which is why getting the dash running now with all the display stuff. I guess the interface doesn't need to be perfect yet.
No, absolutely not.
But just displaying the information is important.
Yeah, the data flow.
Yep.
Up to the screen. Yeah, we can tidy it all, make it look nice down the track a little bit.
Yep.
But fundamental is doing the stuff that needs to be done to get the motor running, and that's as a single block of work.
Yeah, cool.
Beautiful.
Okay. So should we give everyone a little tour of the rest of the bike while we're here?
Might as well. Yeah.
So I can see this cardboard box hanging out the back here. What's this?
So that box there is fundamentally the mock-up of the size of the battery bank. It's a 1700 amp hour or 1800 amp hour battery bank. It'll be a couple of cables coming out that plugs into the controller, but that's fundamentally where the battery's going to mount, just in underneath there like that. We have the controller. Now this is the controller for the motor, and that's just going to hang off this side over here, nice and close to the battery, so all the leads are all short. So that's just going to mount just in there somewhere like that, and so the cables will all connect up. We'll make it all sort of nice. That's one part of the puzzle.
Yeah, cool. And
then the other part of the puzzle, I suppose later on down the track there, is the turbo, and we're gonna mount the turbo just over here.
We're not just to be clear too. We're not actually using this turbo, are we?
No, we're not. No,
it's been a bit of a journey. This one.
Yeah, it has been. Yeah. We actually found a turbo that actually is mounted to Ford Ranger 2.2 litre motors, but they're pretty hard to find. So we'll end up probably buying a new one. But it's actually a step up from this one. This one's just probably a little bit too small. The next one up's just a tiny little bit bigger, but has got better inducer, exducer parameters that suit our bike and the RPM of the motor. Because these things normally spin up around 200,000 RPM. Our DC motor will max out at about 90, so the turbo's got to be able to push good air down at lower revs, and hence the design of the intake
Yeah. So when you say turbo's too small, it is more about low-end airflow that matches the engine intake.
100%.
And ours goals rather than turbo maximum volume.
Yeah.
Where we're nowhere near going to achieve
that's
maximum
exactly
turbo flow. Yeah.
No, we're not interested in that.
No, we're not. No,
we're all about just airflow to suit what our aims are for the motor, and that is to get 6 to 8 pounds per minute flow at relatively low turbo revs. So the design of the cold end, the intake side, has been a really, really, really difficult and quite complex journey. But look, there is an off-the-shelf model, and we're really excited to get hold of it.
Yeah. Cool.
So, but basically, it's going to sit in here like this. The intake's going to be there. Of course, the outlet will now go to where the exhaust used to go. The exhaust will just come through underneath the bike and go straight out. And then the mass airflow meter, the dump valve, and all the plumbing will all be mounted in here, up through to the top and into the throttle body of the KTM. So there's a lot going on in there.
Yeah, cool.
Absolutely, there will be. Yeah, and because the electric motor basically replaces the whole hot end, it hangs over this side, over here.
Yep.
And it's nice and close to where the controller's going to go, so the cables are nice and short, and that makes that like a nice little package.
Yeah, awesome. Awesome.
So that's all stage 2.
Yep.
Stage 1 is just getting the motor running as a naturally aspirated motor, calibrating the mass airflow meter under natural airflow. That way we can extrapolate that calibration when we actually start running higher airflows through the turbo.
Yeah, cool. Yeah, awesome. Awesome.
Right.
Wow.
There it is. Basically the project. Yeah. Rightio, I think that's it for the day.
Yeah, cool.
So thanks for coming over. First RCDC session of the garage.
On to next week. What is next week?
So next week is finishing off a bit more of the dash. Fuel tank. Yeah. Fuel lines.
Yep.
And move towards trying to get the motor running. Wow, what a big day that's going to be.
That's exciting.
That's the first time that motor's run in nearly 3 years.
Oh, let's hope that day goes well.
So confident.
Yeah.